Hi, welcome to section 4.8, Application Problems, Nunez Community College, Math 1400. Today, we'll be doing application problems with right triangles. Typically, we always draw the right triangle having angle A in the bottom left. We have angle B and angle C, with lowercase a being the length opposite side A, lowercase b being a length opposite side side B, and little c being the length opposite side C. So in the first part, we're going to be given some information and we're going to have to find all the missing parts. The first one says that solve the right triangle given that angle A is 34.5 degrees. So we'll put it in the spot, 34.5 degrees, and that little b is 10.5 units long. We want to find little a, the length, little c, the length, and angle b, the angle. So in order to find angle b, we know that the sum of the interior angles of a triangle is 180 degrees. So we know that the two angles that is not the right angle must also add up to 90 degrees. So 90 minus the 34.5 gives me 55.5 degrees. So we got angle B is 55.5 degrees. Now, in order to find A, we are going to use one of the trig functions. I choose to use the angle given and the side given instead of the angle that we found, just to make sure that we're given, we use the right numbers. So angle A, side A, if we're opposite that angle, is the opposite side. Side B is the adjacent side, and side C is the hypotenuse. So in order to find A, we're going to take the angle, we're going to take the side given, looking for this. The trig function that uses opposite and adjacent would be tangent. So we'll do tangent of the angle, 34.5 degrees, is equal to opposite over adjacent, which is 10.5. Make sure that our calculator is in degrees. We're going to hit tangent of 34.5, giving me a decimal approximation of 0.6872. It's equal to A over 10.5. So we're looking for A, bring the 10.5 to the other side by multiplying both sides by 10.5. So we'll get 10.5 times 0.6872, giving us little a, which will be 7.2. A is approximately 7.2. I'm going to label it with one decimal, so 7.2 is what we have for A, the opposite side. In order to find C, the hypotenuse, I'm still going to use the two that were given to me rather than the two that we just found, because if we found the wrong side or found the wrong length, it's not going to give us the right answer. So here we have this angle, we have adjacent, we have hypotenuse. Adjacent hypotenuse is the cosine. So we'll take the cosine of 34.5 degrees is equal to 10.5 over C, the hypotenuse. First thing we're going to do is find our decimal approximation. So cosine of 34.5 will give you 0.8241. That's equal to 10.5 over C. Now we're going to take the two and flip-flop them. C will go to the top on the left, and 0.8241 will go on the bottom. So C is 10.5 divided by 0.8241. And that will give me that C is approximately 12.7 units. This is how we get around and find the missing parts given two parts of the right triangle. So with that example, in example 1, we're finding all the parts. However, on some of them, being that it's an application problem, we have the pictures drawn for us. And when we have this, we're usually looking for a specific answer, like the length of a side or the angle. So in this first one, we have the drawing, which is going to be a tower, and we're going to be standing a certain distance from the tower. So we have our tower, okay, this is drawn. The tower, the tree, the flagpole, whatever we're talking about is always going to be a 90-degree angle. And it says we're from a point on level ground 125 feet from the base of the tower. So from a point on level ground 125 feet from the base of the tower, this is going to be given to us. This is 125 feet from the base of the tower. We have an angle of elevation. An angle of elevation is always an angle from the horizon looking up. Always from the horizon looking up. We have an angle of elevation of 57.2 degrees. Again, given to us 57.2 degrees. They want us to find, based on this, the height of the tower. The height of the tower, which will be our x we're looking for. So for this one here, we're given the angle, we're given the 125, we're finding the height. According to the angle, this height is my opposite side. The 125 is going to be my adjacent side. So we're using the trig function that deals with opposite and adjacent. That would be our tangent. So I'm going to say that the tangent of 57.2 degrees is equal to opposite x over adjacent 125 feet. So now we're going to go in and find our decimal approximation of tangent of 57.2. Tangent of 57.2 gives me 1.5517. 1.5517 equals x over 125 feet. We want to bring the 125 to the left. It goes from the bottom to the top, so it's 125 feet times 1.5517. When we multiply that, we come up to 193.9. So x is 193.9. Since we were in feet, we have feet. This is 193.9 feet. But again, with these problems here, they're only asking one specific answer. They're not asking for us to find all the variables in the triangle. We could also look where we're actually finding, instead of the height or the length of a side, we could be finding the angle that the triangle makes. In this next one, it says a kite flies at a height of 30 feet when 65 feet of string is let out. A kite flies at a height of 30 feet when 65 feet of string is let out. Well, again, they have the triangle drawn for us, but if not, you know that the kite flies at a height, so we'll make our kite up here, and it flies at a height of 30 feet when 65 feet of string is let out. Well, the string goes to the kite, so this is 65 feet of string is let out. They want us to find the angle of elevation that the string makes with the ground. So they want us to find an angle theta. This time, if the angle theta is what we're looking for, the 30 is going to be our opposite side, and the 65 is going to be our hypotenuse. So the trig function that uses the opposite and the hypotenuse is going to be our sine. So we'll do the sine of theta is equal to 30 over 65. Our feet will cancel out on both the top and the bottom. So we look at this decimal, 30 divided by 65, and we get 0.4615. So I have the sine of theta is 0.4615. Now I'm trying to find angle theta. This is the sine of angle theta. So what we have to do is get rid of the sine. So I got theta equals, and I'd be dividing by sine, but your calculator does not work that way. Your calculator is doing the inverse. So what we do here is we write it as sine -1 times 0.4615, and that takes care of the division. So on top of your sign button, you should have a little sign -1 button. So we press the green, hit that, put in the 0.4615, and we look at it, and theta comes up to be 27.5 degrees. Theta is 27.5 degrees. When looking for the angles, we're going to hit the inverse buttons, whether it's the inverse sine, inverse cosine, or inverse tangent. When looking for the sides, we're just hitting the sine, cosine, or tangent button in order to get our decimal. Okay, now it gets a little more tricky, a little more sophisticated, because we have to do more than one thing in a particular problem. So the next one talks about a hot air balloon. So this is the example number 4, talking about the hot air balloon. That is ascending or taking off from the ground. Okay, this next one says you're taking off on your first hot air balloon ride. Your friend is standing on level ground 100 feet away from your point of launch. So again, it's going to be drawn for you, but if you have to draw it, you have the friend standing on the ground 100 feet from your launch. This is your friend, and this is your launch. It already has the balloon drawn going up. Okay? And it's 100 feet away from your launch. This is going to be our right angle right here. And it has, and it's taking video of your face as the balloon is ascending rapidly into the air. At one instant, the angle of elevation from the video camera to your face is 31.7 degrees. At one instance, the angle of elevation from the video camera to your face is 31.7 degrees. Then it says 1 minute later, the angle of elevation is 76.2 degrees. So in 1 minute, the balloon has traveled this far up, and the angle of elevation now is 76.2 degrees. Remember, that's the total angle, not from where it was. This is the original angle, okay? And they want to know, during that minute, how far did the balloon rise? During that minute, how far did the balloon rise? So we know that we started here. This is A, or X, if you will. That's where we start. And in 1 minute, or 1 minute later, sorry, the balloon was this high. We'll call that B. They want to know during the 1 minute time, how far did the balloon travel? So it started here and it ended here. So this distance here, which is going to be X, is going to be the total distance B minus where we started with A. So we know that X is going to be B minus A. So what we have to do here is we have to figure out not one, but 2 different triangles. So I like to lay it out as the first triangle, which is the 31.7 degrees, 100 feet away, and we're finding A. Then I'll want to find the second one, which is the 76.2 degrees. This is going to be B. Okay, still 100 feet away. And then what we're going to do is we're going to subtract B from A to get our X, which is how far of a distance it went. So in both of these, the 2 things that are given and the side that we're looking for was going to be the opposite side in both. The opposite side in both. And the 100 feet is the adjacent side in both. So we will be using the same trig function for each, which is going to be the tangent. In the first one, we're going to have what? Tangent of 31.7 degrees. is equal to A over 100 feet. In the second one, we're going to have tangent of 76.2 degrees is equal to B over 100 feet. So let's look and see what we have here for our decimals. The first one is going to be tangent of 31.7, giving me 0.6176 equals A over 100. When we bring our 100 over here and we multiply, the decimal goes over two spaces. A is going to be 61.7 feet high. And on the other one, we got the tangent of 76.2 degrees. That's going to be 4.0712 B over 100. Again, when I bring that over, it brings the decimal over 2. So B is going to be 407.1 feet. So now we're looking for X, and remember, X, this distance here that we're looking for is going to be B minus A. The whole thing minus this much. So X is going to be 407.1 minus 61.7. And that gives me 345.4 feet. 345.4 feet. So within that distance, within that time, the balloon traveled from here to here, which is a distance of 345 feet. But if you're given this, where you have, it looks like two triangles, one within another one, that's what we do. I like to separate them into the two and then figure out what we need to do in order to get what they're asking. But the triangles will be drawn for you, so therefore you should be able to decipher it instead of having to put it all together yourself. Okay, now we're going to talk about bearings. Bearings is the direction that something is traveling. A lot of times we'll use bearings if you're talking about planes or ships or something where you can't really see the object because it's too far away. If you're trying to fly from New Orleans to Detroit, you are going to have a plane that's going to be flying at a bearing because you want to make sure you end up in Detroit and not another city. So what we have is a bearing, and bearings start out with a north or south heading. So we look at a compass, if you will, where up is north, down is south, to the left is west, and to the right is east. So for a bearing, we have either a north or south heading. Then we have an angle, and the angle is off of the north or the south. Then, after the angle, we have the direction, which is either left or right, or east or west. And together, all of that will make a bearing. So for example, suppose this is my angle. This angle is going to be a ray. We'll put this as O, where the origin would be, and we'll put this as point A, so that we have our ray that is going from O in the direction of A. And we might have a number here, suppose it's 30 degrees. The angle is always going to be off of either the north or the south. This bearing for OA, the bearing for OA is going to be towards the north, because it's got to be north or south. That's the first thing. It is towards the north. How far off of the north is it? It's 30 degrees off north. That would be my angle. And then in the direction of to the right or to the left, it's going to the right, so towards the east. This would be the bearing of ray OA. This would be the bearing of ray OA. So if I put a couple of other ones up here, suppose I had OB, and this would be 25 degrees. If I'm looking for the bearing for ray OB, I'd have what? North, because it's going up, so it would be north. How far off of the north? 25 degrees off the north. And then what? Towards the left, so it'd be towards the west. So the bearing of OB would be north 25 degrees west. If I was doing this one here, we'll call this OC, and this is my angle, and suppose it would be 47 degrees. If you try this one, it's towards the south, so the bearing of ray OC would be south 47 degrees to the east. South 47 degrees east. But you have to be careful, because suppose we have ray OD and my angle is here, 10 degrees. The angles that we have are all off of the north or the south. This one here, the angle is from the east. So what we have to do is we have to find the angle off of the north or the south. Each one of these quadrants is 90 degrees, so it's 90 minus 10 would give me 80 degrees. This ray, OD, would have a bearing of north 80 degrees east. North 80 degrees east. So if it is off of the east or the west, you have to make sure that you know what angle is coming off of the north or the south. This one here, suppose we had 75 degrees, and suppose this was OG. If I'm looking for ray OG and looking for its bearing, it would be what? It would be from the south. For this angle, 90 minus 75 is 15 degrees. So it would be south 15 degrees towards the west. And that is bearings. The reason that they say it is that our last question is a question that we're going to have to use bearings in order to draw. So the last example, is going to be a ship leaving in harbor. A ship leaving a harbor. So it says, a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. A ship lives, or a boat leaves the entrance to a harbor. Leaves the entrance to a harbor and travels 25 miles at a bearing of north 42 degrees east. So that would be my north, south, east, and west. North 42 degrees, 42 degrees. And here's my ship, and it went 25 miles. That represents my distance, 25 miles. After traveling 25 miles, the captain then turns the boat 90 degrees clockwise and travels 18 more miles. So I'm going to put another compass up here. So after traveling 25 miles, he then makes a turn 90 degrees, so it's a 90-degree angle, and travels 18 miles. And luckily, they give us the new bearing. It says it travels 18 miles on a bearing of south 48 degrees east. South 48 degrees east. It then wants to know, at that point, how far is the boat? How far is the boat from the entrance of the harbor? Harbor entrance, here now is my boat, okay? There's my boat, and we want to know how far is it from the entrance of the harbor. So we are looking for X, that distance. Now, what we want to do first is say, well, it's a right triangle because he made a 90-degree turn. We have two sides of a right triangle, so we can use Pythagorean theorem to find the distance that the boat traveled away. And remember Pythagorean theorem, a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. So it's going to be what? 25 miles squared plus 18 miles squared equals x squared. And 25 miles squared plus 18 miles squared is going to be 949 miles. So x squared is 949 miles. Take the square root of both sides. Take the square root of both sides. And x is going to be approximately 30.8 miles. 30.8 miles. So the boat is approximately 30.8 miles from the harbor. From the harbor entrance. But then it asks, what is the bearing? What is the bearing to the nearest degree from the boat to the harbor entrance? So it wants to know what is the bearing of the boat from the harbor entrance. So if something might have been happening to the boat, they need to know where it's at to send help. They need to get that bearing. So in order to do this, we have to find theta. Then we have to what? Add 42 to it, and that would give us the angle in order to do the bearing. So we have what? A right triangle. I'm looking for theta. What am I given? I'm given the opposite side. I'm given the adjacent side. So therefore, opposite and adjacent is going to be tangent. So tangent of theta is equal to opposite 18 over adjacent 25. So now we have what? 18 divided by 25 gives you 0.72. So tangent of theta is 0.7200. We're looking for theta, so that's what? Tangent inverse of 0.7200. And the tangent inverse of 0.7200 is 35.75 degrees. Theta is 35.75 degrees, which means it is this angle, 35.75 degrees. The bearing, though, is going to be from the north, so it's going to be 35.75 plus the 42, giving you what? North. That's going to be what? 87.75. 87.75, and the two of them together, degrees, and it's towards the east. So the bearing at that time is going to be north, 87.75 degrees east, and the boat will have been 30.8 miles from the entrance of the harbor. This has been section 4.8, application problems for Math 1400, and I'll catch you at the next one.